Alright, there's a little magic 5 for today, if you want to get a little magic there. So we're actually going to do two quick lessons today, 9.2 and 9.3. They both have to deal with the Pythagorean theorem. So the Pythagorean theorem that we normally all talk about is a squared plus b squared equals c squared. And usually, most of the time, people who do these problems, they do put c for the hypotenuse. But every once in a while, you may see c in a different place. So really what you want to make sure that you understand is it's a leg squared plus a leg squared equals the hypotenuse squared. Okay, so it's the two perpendicular sides, each squared and then added together, and that's equal to the hypotenuse squared. So that's one thing you want to make sure that you understand. It's not necessarily these letters that are so important. It's this idea here. The next thing we want to talk about are Pythagorean triples. So that is where all three of these sides are natural numbers. Another name for natural numbers are the counting numbers. So those are the most basic numbers we start off with in life. 1, 2, 3, we learn how to count. And then maybe eventually we learn about the concept of zero, and then later on negatives and fractions and all that stuff. So some Pythagorean triples, we've run into some already this year, but you really should remember the 3, 4, 5 and the multiples of 3, 4, 5. And then, so that would be 6, 8, 10, multiply it by 2, multiply it by 3, etc. Multiples. And then the other one is 5, 12, 13. And it's multiples as well. Now there are other ones. They're probably infinite, I would suppose. But these are the two that show up, or they're multiples, on standardized tests and on homeworks, assignments, PSATs, because when people write math questions, they know that these numbers work, and so they choose them a lot. So you really want to have these memorized. Alright, and I think that leads us into our first question here. So find the length of the hypotenuse of a right triangle if the legs are 7 and 24. So, and then tell whether it's a triple. So the legs are 7 and 24. So 7 squared plus 24 squared equals the hypotenuse squared. And anytime we're in control, we're going to call the hypotenuse c. So that's going to be 49 and 576 if you need to. You can do it on the side over here. There's nothing wrong with doing a little math out like that, arithmetic. 576. So if we add those together, so we have 576 and 49, that is 625. So we have 625 equals c squared. So if we square root both sides, then we're going to get c equals 25, and yes, that's a Pythagorean triple because all three numbers are counting numbers, 7, 24, and 25. Okay. So find the length of the leg of the right triangle in this picture. So the legs, so that's going to be x squared plus 12 squared equals 6 root 5 squared. Now in your work, you probably could have just put 144 for that. This one might be a little bit trickier, but if you square 6, you get 36. Because these are multiplied together, you can just distribute it. If they were added, we would have to use FOIL. But because they're multiplied, we can distribute. This is going to be 36 times 5 is what we're going to get out of that, 36 times 5. So that's 150 plus 30, so that's 180. Okay? So if we subtract 144 from both sides, and it's a good idea if you find yourself making little mistakes all the time or frequently, to actually show your work like this. It just helps your brain organize the information. So we're going to take the square root of both sides. Now remember, when we take the square root of x squared, we get the absolute value of x. And so technically we would have plus or minus 6, but because it's the length of a side of a triangle, that negative answer doesn't really make sense. So the answer is just 6. And there's no units on there, so we don't have to worry about that. If there were units on there, we would want to make sure we put units on our answer. So hopefully you get this is pretty easy for you. You're like, yeah, I know this. So we'll just keep moving through here. Find the area of the triangle. So the first thing is you need to know the area of a triangle formula. So the area of a triangle is 1/2 the base times the height. And when we think about the base and the height, we want those to be perpendicular to each other. So we'll use 10 for the base, so that's going to be 10 meters. And now we need to find the height. So to find the height, we need to look at this situation over here. So because this is an isosceles triangle, by the base angle theorem, these are going to be congruent also. If we have two equal sides, we have two equal angles. And so also this is going to, if it's the perpendicular there, the altitude in an isosceles triangle, that's going to bisect that. So this is going to be 5. So now we're kind of focused on this triangle on the side over here. So we can say h squared plus, and here's what I was talking about up there, like instead of putting 5 squared, we could go ahead and put 25 there. That would be okay. And the same thing here, instead of putting 8 squared, we could put 64. I think we're all probably good to do that. And so h squared equals 9, borrow off of here, so 39. So that's going to be root 39. Now, that is not going to simplify. So maybe some of you are thinking, oh, 3 times 13, but that's not helpful because those are not perfect squares. So we only reduce radicals if we have a perfect square factor, and 3 and 13 are not. So almost done here. Half of 10 is 5, and then we have root 39. And here you can see we have meters times meters, so that's going to be meters squared, which we should know anyway. Alright, and the next one here, right triangle has a hypotenuse of 18 and a leg of 12. Find the other leg. So I'm just going to put A. You could have chose B, it's fine, but so a squared plus 12 squared, so that's going to be 144, equals 18 squared. So I don't have that one memorized, so I'm going to do it over here. So 64, there, and 8 and 0, so 12, carry the 1, 324. So subtract 144. Don't reach for your calculator, your phone all the time. Do some math by hand sometimes just to keep your practice up. Don't always type everything in the calculator. That's not going to help you, especially when we're back in person. If you've been using calculators to do everything this whole time on distance, it's going to be hard when you go back. Okay, 0, we need to borrow off of here. That's going to be 8, 180. Now, that looks familiar. I think we had 180 up there. So we're going to take the square root of both sides, and we're going to get, so we need to factor this. So hopefully everybody sees, hey, I could divide that by 9. So you say 9 and 20. But what you need to realize if you do that is that this could go again. So really that would be 9, and this would be 4 and 5. And so what I would do in that situation is put those back together. So I would have root 36 and root 5. And that would be 6 root 5. And there were no units on there. So that would be good for that. Alright, and you should notice that was up here on example 2 as well. So, okay. And one more for this. So we have these word problems. We've had these on the test all year in different forms. So we want to make sure we pay attention to that. So one of the things as we read this is you'll notice that the hypotenuse is compared to the shorter leg and the longer leg is compared to the shorter leg. So since that was mentioned twice, we want to make sure that we make that our variable. So that's going to be x. And doesn't hurt to have a picture, especially in geometry, but also in higher level math, there are some questions that really a picture is quite helpful. So, sketching a right triangle quickly. It doesn't have to be perfect, we just want to get an idea there. So the hypotenuse, so first of all, we just said both these are compared to the shorter leg, so that's what we're going to use for x, comparing to the shorter leg. Now, the hypotenuse is 2 less than triple. 2 less than triple. So if we triple it, and it's 2 less than that. So that's something we've been trying to emphasize all year. When it's less than, we need to make sure it's not 2 minus 3x. We need to kind of flip-flop that, so we want to keep track of that. And then the longer leg is 2 more than the shorter leg, so that's just going to be x plus 2. So probably not the most accurate drawing, but that's okay. Alright, so now we should be ready to, using that information, we've set up a picture, we've set something up here, and now we want to write an equation for that. Well, we have the 3 sides of a right triangle, so that is going to be the Pythagorean theorem. So we're going to go into the quadratic formula right here. So we're going to put x squared, the leg, plus. So this is a question that's most likely going to be on a Canvas part of a test. So you want to practice this and make sure that you can do this. Just practice it until you have it kind of memorized how to do each step. So we're going to have to FOIL on these. And so hopefully you remember how to do that. If you don't, so it's going to be x squared, and then so you could write it out like this, x plus 2 times x plus 2 if you want to get a better look at it. And so we're going to get x squared plus 2x is 4x, and 2 times 2 is 4. Another way to multiply those out, we've probably shown this already somewhere, but just in case, 3x minus 2, 3x minus 2, and then you treat it like a Punnett square, and you get all those boxes, and so then it would be 9x squared, and then minus 12x, and then plus 4. So if we subtract 4 from both sides, this will go away, and so then we would be left with, kind of want to do another step here, but move all this stuff over. So there's 2x squareds here, so if we subtract 2x squared from both sides, we would get 7x squared. You want to be careful about skipping too much though, because it's easy to make little mistakes. And then here we can factor out an x, so it's going to be 7x minus 16. So this is the zero product property. When we multiply two things together and the answer is 0, then one of those must be 0. So x is either 0 or, solve this for 0, so that would be 16 over 7. So 16 over 7. And if you look at this though, 0 doesn't work, because if we plug 0 in here, we would have a negative hypotenuse. We would also have a 0 short leg. Neither of those things make sense, so that's not going to work. So we're just going to have that answer. So you want to make sure you are careful to check to see if that happens on the test. So practice that question. We'll probably have another one of those in a warm-up, so that would be good. Okay, factoring is really important in Algebra 2. We do a lot of factoring. So when a does not equal 1. So a couple things we look for: is there a GCF, question mark, and can we factor again, question mark. So those are things that we're looking for. So the way we do this is you just need to memorize this process. So you take 1 over whatever that coefficient is, and then you write that down, 3x and 3x. Okay? So the next thing we look at is the sign here. That's positive. That means they both have to have the same sign. And since this is positive, then we know both of those are going to be positive. Okay? The next thing we do is we take a times c. So this is a and this is c. So that's going to be 30. And we figure out what factors of 30 add up to 17. Okay? So if you're not sure, you just start listing all of them. And we got that pretty quickly. These are both the same sign, so we're adding them together. So I need the factors of 30 that add up to 17. So that we're there already. So that goes in there. And then the last step there is to factor out. So here we could factor out a 3, and we should be able to factor stuff out of either one or both of these that will cancel that out, and that's what's going to happen here. We can factor a 3 out. So this, nothing factors there, that's 3x plus 2. This we could factor a 3 out, so divide both those by 3, and you get x plus 5. And that's our final answer there. Okay? So again, and that does not factor again. Neither of those factor. So here, no GCF. So again, memorize what to do. Pause, cover this up. You should be, hopefully, if you were thinking about that, you should be able to do this problem right now from your memory as much as possible. That'll help you practice. So that's going to be 1/8. That's going to be 8x and 8x, like so. Then I'm going to move over and check the sign here. So this is positive. That means they both have to have the same sign, and I see a negative here. So those will both be negative. Okay, and then it's the same thing. You just memorize. A lot of math is just memory, really, memory and practice. So a times c is going to be 40. So we need two factors of 40 that add up to 22. Well, I'm not going to put one. I'm just going to go straight to 2 and 20. So sometimes you'll spot the two factors immediately, and you could just go to the factors. And it doesn't really matter if you put the 20 here, the 2 here, because these are both negative, so that doesn't really matter. So we're going to factor out a 2 out of there. So that's going to leave us with 4x minus 1. So that 2 will change this to a 2 over 8, which is 1/4. And then here we can factor out a 4. So this also helps us figure out what we need to factor out if we're not sure. So if we divide that by 4, we get 2x minus 5. And you can have these two things switched because the commutative property of multiplication. 2 times 7 is the same thing as 7 times 2. Well, they're equivalent. It's not the same. They're equivalent. So it doesn't matter if we have those flip-flopped. All right, so we're going to try that again. And so this is what I've suggested. Like, try not to look at that. Cover that up with your hand. Whoa. Earthquake. No, just kidding. Okay. So cover this up. Don't look at it. And then you try it again because you're practicing. The whole point is, the point of these notes is not to just have these notes done. I mean, that is helpful to be able to look back at them and review, but the purpose is to practice. Okay, so I'm going to accelerate through these last two so we can move on, but no GCF. This is negative, so that means that these signs are going to be opposite. So now it kind of matters where I put stuff. I have to make sure I'm thinking about those signs. So here, a times c is going to be 120. And because these are opposite signs, I'm going to be subtracting the factors. So I need two factors of 120 that subtract to give 14. So I'm going to skip down a couple and try 3 and 40. So 40 minus 3 is 37. That's not good. So I'm going to skip down a little bit more, and 6 and 20. And that works. So I want it to be positive. So I want the 20 to be positive and the 6 to be negative. 20 minus 6 is 14. Okay? So you don't have to listen, but when you start jumping around, you could lose track. And so that's why sometimes we suggest just go in order. But kind of up to you. So, almost done with this. We're going to factor out a 2 here, so that's going to be 4h minus 3. And we're going to factor out a 4 here again, so that's going to be 2h plus 5. Okay? And here, 1/3, 3z. 3z. Okay, that's negative. That means the signs need to be opposite. So we need a plus and a minus. Not a big deal where you put those two, but then when you put the numbers in, it is a big deal. So a times c. Technically it's negative 90, but I usually just put 90 because I know I'm subtracting the factors. So, and the factors kind of match up that way anyway, so hopefully it's not that big of a deal. If you're confused though, let me know and we can talk about it. So again, I'm going to skip down maybe 3 and 30. 30 minus 3 is 27. I need to go farther. So 9 and 10. Well, no, obviously that's 1. That's too far. So somewhere in between here. So we need something. Well, it ends in a 0, so it's divisible by 5. So, or 6 as well. 6 and 15. That's not going to work. 5 and 18. 50 and 40 is 90. And 18 minus 5 is 13. So that's it. And here I want the 18 to be negative and 5 to be positive. Nothing factors out of here, so that's going to be 3z plus 5. And here I can factor out a 3, so we're going to get that. Okay. So we're going to move right on to this review question from section 9.1, and these can get a little bit tricky, so let's see what's going on here. So this is where we have the geometric mean, and the first thing I notice is that we have this x, and we have 2x right here. And the only number we have is 8. So what I'm focused on is that the altitude here is the geometric mean between the pieces of the hypotenuse. And so that's what I'm going to do first. So the altitude is the geometric mean. So I know that's going right there, between the pieces of the hypotenuse. So we have that. And then we could reduce this. 8 over 2 is 4. So now if we cross multiply, we're going to get x squared equals 32, or you could leave it as 4 times 8, but we square root both sides, and this is 16 times 2. So x is 4 root 2. So this is 4 root 2, and this is twice as big as that, so that's 8 root 2. Now this whole thing is going to be 12 root 2, which we need for some of the other relationships here. So now I'm going to find a, just because it doesn't matter. A and b is going to be a similar process. So the leg is the geometric mean between the piece closest to it and the whole thing. The leg is the geometric mean between the piece closest to it and the whole thing. So that tells me that I'm going to have a here and here. So the piece closest to it is 4 root 2, and the whole thing is 12 root 2. Okay, so if we cross multiply that up, we're going to get a squared, and here we're going to get 48 times 2. It's getting kind of cumbersome here. How do I want to do that? Maybe I would prefer to... Okay. I guess I could do 48. I'm not really excited about it though. 48 times 2. Hopefully you remember, we asked you, I think earlier in the year, 32 and 48. 48 is 16 times 3. So now we can kind of break it down like that. You can break this down any way you want. If you want to go 96 and then start factoring that, that's fine. But we know that we're about to take a square root, so I was trying to get a perfect square in here. So it's 16 times 6. So that's going to be 4 root 6. So that may have been a little bit of confusion there. You can come in office hours and we can talk about some different ways we can try to reduce that square root there. And now we're going to do b, and b is going to be almost the same setup as this. So the leg is the geometric mean. So we have that on both of those. The leg is the geometric mean. And between the piece closest to it, so that's 8 root 2, and the whole thing, so that's 12 root 2. Okay, so cross multiply on that and see what happens. And now this again is going to be, I get b squared, so I know I'm going to be square rooting over here. So if I look at this, I've got root 2 times root 2, that's going to be 2. And 2 times 8 is going to be 16. So that's 16 times 12. but 12 is 4 times 3. So the whole point of what I'm trying to do in my head is, like, as I multiply those, is I'm trying to find perfect squares, because I know that's going to help me out. Now at this point it's kind of up to you. I would probably go, I know that that's 64, so I would probably just do that, and then that's going to be 8 root 3. Alright, so that's nice. Now, unfortunately, this is going to be a little bit on the longer side because we have another one to do here. So, it's still related to the Pythagorean theorem. And what we're looking at here is the converse of the Pythagorean theorem. So if you know what the three sides are, you can check to see if you square the two smaller sides, and then you know it's a right triangle. Okay, so that's what we can look at here. So if we take two smaller sides, 7 squared plus 10 squared, I guess I kind of do it backwards from that, but I take the two smaller sides, square them, and I'm comparing that to the largest side squared. So this is going to be 49 plus 100. Now, when you look at this, hopefully you know that if you square 13, you're going to get 169. So this is going to be more, 169 plus, because we also have this 0.4 that's being squared as part of it. I don't want to write all that out because I can see that 169 is more than 149. So those are definitely not going to be equal to each other. So no, this is not a right triangle. Okay, so hopefully you understand what I'm saying there. We literally could, if you want to, you could put 13.4 times 13.4 and see what happens, but it's kind of, it's up to you. Alright, so over here we're going to do the same thing. So 6 squared, again, I guess I could have just, well, let's leave it. So 6 squared plus 12 squared compared to, hey, 6 root 5. We saw that twice already in the other section. So this is going to be 36 and 144. This is going to be 36 times 5. That's 180. This is 180. Those are equal to each other. So yes, that's a right triangle. So pretty easy, very similar to what we were just doing. Now here's the twist, and this is important. If we look at these, so we can tell what kind of triangle it is. So if the smaller sides added together, okay, so let's think about some things here. So this is the biggest side. If the biggest side squared is less, then it's acute. Okay? If the bigger side squared is less than the other two, then it's acute. If the bigger side is equal to the other two, it's right. And if the big side squared is greater than the other two, then it's obtuse. So this is, you need to memorize this. Alright, so this is actually a two-step process, so you want to make sure you're very careful here. So the first thing that you have to decide is, are they a triangle? Could this make a triangle? So what you want to do here is you need to take the two smaller sides and add them together and compare it to the bigger side. So this is 26. 26 is greater than 24, so it is a triangle. If this is not true, then we're done. We don't have to do any more work because it's not even a triangle. Remember, these two sides have to be longer than this side so that they can actually make some angles. Okay, now once you do that, then what you're going to do is this right here. So you're going to square them. So let's see. So if we take 24 squared and we compare that to 8 squared plus 18 squared. So 24 squared, we had that the other day too. That's 576. But again, if you don't remember that, you could write it over here. And this is 64. And 18 squared, maybe we don't know what that is. I think we had that before as well. So that's 144 and So 324. Okay, so the way we look at this is the bigger side squared is bigger. It's bigger, and so bigger angles are obtuse. So that's going to be obtuse. Okay. So let's try that again. So over here, we're going to take the two smaller sides. So 3.2 plus 4.8. That's 7, 8. That's 8. 8 is greater than 5.1. That's true. So it is a triangle. And so now we can test that out. See what's going on here. So we're going to have 3.2. I'll do 5.1. 5.1 squared compared to 3.2 squared plus 4.8 squared. Okay, so that is going to be 26. Now we don't have to do everything by hand. We got some decimals here. We could probably just type that in our calculator and see what we have going on there. So this is 10.24 and this is 23.04. And you have on your phone, you should have a calculator. If you've never used that, you should check that out. So here the bigger side squared is less. The bigger side squared is less. So that's an acute triangle. Okay, acute triangle. Alright, so let's try to move through this pretty quickly and wrap this up. So remember, we highlight test questions. Factoring is always something that could be on a test, so we want to stay aware of that. So your friend, you want to make sure that a room is rectangular. So if they built it correctly, it should be a rectangle probably, unless they're trying to be artistic and have something else. So your friend measures the four sides of the room to be 9 feet, 9 feet, 40, and 40 feet. And he says that proves that the wall is rectangular. Okay? So does that prove it's a rectangle just because you have two 9s and two 40s? Now, I assume that the two 9s aren't in a row because that would make it a kite. So that would be, hopefully that would be pretty obvious, especially if it was 9 and 40. If the two 9s were in a row and then the two 40s were in a row, that definitely wouldn't be a rectangle. So I'm assuming it's 9, 40, 9, 40. So does that mean it has to be a rectangle? Opposite, assuming opposite sides congruent. Is that enough? Well, opposite sides congruent means that you have a parallelogram. But a parallelogram doesn't have to be a rectangle. So, no, he's not correct. It might be. But it has to be parallel. Remember, to be a rectangle, you have to have 4 right angles. That's what makes it a rectangle. So you measure the diagonal to be 41 feet. Now, how can you use that to prove what's going on here? So if we draw this out like this, and this doesn't have to be perfect, we're just trying to get a picture to help us do this. So, so we've got 9 feet and 40 feet, and then you measure the diagonal across there and you get 41 feet. Well, hopefully you realize that ties into today's lesson. So what we're wondering is 9 squared plus 40 squared compared to 41 squared. Okay, so this is 81, and this is 1600, and 41 times 41 is 1681, and that's 1681, so they are equal. So we have a right triangle, and this is 9 and 40 also, which is going to make that a right triangle, which now is going to make all of those, this a right triangle, which will make that a right angle. So these are all right angles. So yes, that will be enough to prove that we have a rectangle. Okay? Alright, so now, factor. So there's a GCF here, and that is 3y squared. So I like to put that down here, 3y squared. And then when you factor that out of there, that's going to be 6y squared plus 5y minus 4. Okay, and so then, now we just practiced some of these. We didn't have that first step in there, but so this, if you recall, this is where we put 1/6, and then 6y, and 6y, and it's negative, so they're going to be opposite signs. And then a times c is going to be 24, so I need factors of 24 that subtract to give 5, so hopefully 3 and 8, that's a positive, so that's going to be 8, and this is going to be 3. So finishing that up, we can divide this by 2, so that'll be 3y plus 4, and we can divide this by 3, that's going to be 2y minus 1. So that's what we'll get there. Now, I'm going to make the last 3 of these optional, so I'm just going to put the answers down for you. And if you totally get it, that's good, but factoring is really important to Algebra 2, so that's why we have so much factoring in our notes. So I'm just putting these answers down, so you can pause it and try them yourself unless you're 100% sure that you know how to do them. And if you have questions on any of these, come to either of our office hours and we will go over them with you. We can fill these out in person on the Google Meet. So that is about it. It's about that time. Come back to either of our classes if you have questions. Have a good day.